Welcome to Homework Lib.
Hi, so for this question, what we are required is that we are considering the weak acid dissociation in aqueous solution of this compound plus water, as always, that is going to generate H3O plus, the hydronium ion, or H plus to abbreviate, plus NO2 minus in aqueous solution, right? So we want a solution that has a pH equal to 2.5. That means that the concentration of H3O plus needs to be equal to 10 to the minus 2.5. And we're given the pKa of the acid that is 3.33. Nice. So in order to find the value for the concentration, we can start using our ice table in molarity. In water, it really doesn't matter because it's a pure substance and it's a liquid. But let's call the initial concentration of HNO2 as C0. At the very beginning, before dissociation happens, I have 0 of hydronium and of NO2 minus. Next up, an X amount, it's going to dissociate, generating a plus X and plus X in both of the sides. And at equilibrium, I'm going to have C0 minus X, X, and X. So now, in most of the problems of this type, we are used to solving for X. But if you notice, in this scenario, we're given the value for X because this is going to be the concentration of H2O plus that we require. And that value is 10 to the minus 2.5 as we mentioned at the very beginning. Correct? So the next step is going to be write down our acidic constant equation. Remember that this is concentration of H2O plus, concentration of NO2 minus. Both of those concentrations are going to be the same, divided by the concentration of HNO2. Perfect. Since the pKa is equal to 3.33, that means that we can get the value directly for Ka. And Ka is going to be 10 to the minus 3.33. Okay? So we can use directly that value. Let's replace everything here. 10 to the minus 3.33 is going to be equal to this concentration that was 10 to the minus 2.5 squared divided by the initial concentration minus 10 to the minus 2.5. We need to solve for C0. That looks like C0 times 10 to the minus 3.33 minus 10 to the minus 2.5 times 10 to the minus 3.33. It's going to be equal to 10 to the minus 5. Remember that by exponent laws, these two multiply each other, so I have a minus 5. On this side, we have the same base. We are doing a product, so we need to add up the exponents, right? So minus 2.5 plus minus 3.33. This term goes into 10 to the minus 5.83. Okay. Now isolating for C0, we have C0 is equal to 10 to the minus 5 plus 10 to the minus 5.83 divided by 10 to the minus 3.33. Plugging in all of those values gives us an initial concentration of 0.0245 molar. which is approximately 2.5 times 10 to the minus 2 molar concentration of HNO2 in aqueous solution. And that will be all. You can verify the result. Always verify things twice just to check that you didn't make any mistakes in the calculators. And that will be all. So this is our final answer.